Hi, this is Saida Khadija. Today I will be classifying the organometallic Vaska's complex, and the formula for it is iridium 1-chlorocarbonyl bis triphenylphosphine. The four classifications I will be going over will be the nature of the central metal, the type of the donated electron pairs, hapticity, and hard and soft interactions. The complex has iridium as central metal in +1 oxidation state, and iridium has 9 valence electrons, and because of the oxidation state it makes it a D8 electron configuration. This complex is a square planar and has 4 ligands. The ligands are carbonyl, 2 triphenylphosphines, and 1 chloride. These ligands donate through a single atom, and the complex has 16 electrons in total, which is typical for square planar D8 complexes. For classification A, I'm going to go over nature of the central metal, and I'm going to be focusing on iridium. It is categorized as low valent since oxidation state is +1. In late 5D transition metal atoms on the periodic table, it's square planar since all 4 ligands are on the same plane, 8 electrons from iridium and 2 electrons from each ligand, making it a 16 electron arrangement. It usually goes under oxidative addition to reach 18 electron state. It is a soft, highly polarizable metal. Now using LX system to classify the ligands in this complex. Carbonyl ligand is a neutral 2 electron donor, and the 2 triphenylphosphine ligands are neutral 2 electron donors. Chloride is the only anionic 2 electron donors in this complex. So this complex can be categorized as iridium L3X species. Moving on to hapticity, it tells how many atoms of each ligand attached to the metal. Carbonyl is through carbon atom, so eta 1. Triphenylphosphine is through phosphorus, so eta 1. Chloride is through chlorine, so eta 1. Since all 4 ligands are eta 1, this categorizes all ligands as eta 1 monodentate ligands. And the complex is square planar coordination. Now moving on with hard and soft acid-base classification. I'm going to be using this chart for iridium and chlorine. Iridium is a soft acid in this complex because of its oxidation state +1, even though usually categorized as borderline acid if it's in the high oxidation state, like it shows in the chart. Iridium is a large and polarizable 5D metal, and chloride is not fully hard, neither fully soft, so borderline. Carbonyl donates electrons to the metal through sigma donation, but it accepts electron density back into its empty anti-bonding pi orbitals through pi back bonding. Since carbonyl is highly polarizable and has low energy anti-bonding pi orbitals, it acts as a soft base and stabilizes low valent metals like iridium. Looking at the triphenylphosphine, the phosphorus atom has a large polarizable lone pair. It donates to the metal through sigma bonding. The 3 phenyl rings attached to the phosphorus spread out electron density, making the ligand even more flexible and polarizable. Triphenylphosphine is a soft base. This makes the overall complex to be categorized as being dominated by soft-soft interactions. Thank you for watching, and this is my reference.